Scenario 4. You are a NASA engineer. You have recently been promoted to oxygen engineer aficionado. Your first task is to determine how many grams of oxygen are on a space shuttle upon entering space. If your calculations are incorrect, your astronauts will die a slow and painful death. What factors do you need to take into account in order to solve this problem? What gas law applies to the situation?
The ideal gas law applies to the situation.
Resolution to scenario. Pressurize the air in the space shuttle to the equivalent of 1 to 1/3 of an atmosphere. 1/3 of an atmosphere is the minimum pressure a human needs to survive in space or anywhere else. If there is not a sufficient amount of oxygen, the lack of pressure will cause the lungs to expand, causing suffocation. Suffocation occurs because there is not enough pressure pressing down on the lungs when you exhale.
You need to consider pressure. If there's not enough pressure on the lungs, they expand due to the lack of air weight on your lungs, meaning you slowly suffocate until you die. Volume. The pressure has to change according to the amount of volume it needs to fill. Moles. The problem is asking for the number of grams. Therefore, you need to know the number of moles to solve for the number of grams. Temperature. Temperature affects the amount of pressure and volume because it can either give or take away kinetic energy to where less or more collisions would occur. The equation we use is PV equals nRT. N equals the number of moles. R equals universal gas constant, 8.3145. And K equals 0.0821. V equals volume, P equals pressure, T equals temperature. The ideal gas law is seen as rising kinetic energy in variation with rising kinetic pressure of gas molecules, which collide with the boundaries of their containers to maintain the pressure. The collisions with the boundaries of the constant are elastic collisions, meaning that there is no net loss of kinetic energy. It corresponds to the kinetic molecular theory. The red balloon represents the lungs of the astronauts. As air pressure is good, the lungs are a good size. But as the air pressure decreases, the lungs expand, causing the astronauts to slowly suffocate until all of a sudden they're dead.
And there it is.
This is the ideal gas law.